Our today's lecture is about vector atom model, which is given by Allen Buck and Goldsmith. In the last lecture, we discussed about the Sommerfeld atomic model. And according to Sommerfeld atomic model, the electron is moving in an elliptical path and the motion of the electron is relativistic, and this model mostly explain the fine spectra. But the Sommerfeld atomic model have some limitations, and one of the limitations of the Sommerfeld atomic model is that it explains the fine spectra. It gives the reason behind the spectral lines of H alpha, H beta, and H gamma lines, but it does not give the correct number of the spectral lines obtained in the hyperfine spectra. Second, it does not discuss about the intensities of the hyperfine spectra or the fine lines of the spectra. Third limitation of this Sommerfeld atomic model was that it was unable to explain the Zeeman effect, that is, the phenomena in which when a spectral line is placed in a magnetic field, it gets splitted into 3 or into 4 or into 6 parts. It depends whether this magnetic field is applied perpendicular to the spectral line in this way or in this way. Fourth, it is also unable to explain the Stark effect. In Stark effect, now the spectral line is placed in between the magnetic field. On one side, we have a positively charged plate, and on the other side we have a positively negatively charged plate, and the spectral line is allowed to come through this electric field, and when it passes through this electric field, the spectral lines undergo splitting, and this effect is known as Stark effect. This Sommerfeld atomic model was also unable to explain what will happen if there are two or more than two valence electrons in the outermost shell. These are the limitations of the Sommer atomic spectra, and these limitations are overcome with the help of vector atom model, which is given by the Allenbeck and the Goldsmith. According to vector atomic model, there are now two new assumptions taken regarding the motion of the electron and shape of the orbits. The two important characteristic or the two important features of the vector atomic model was that one is the spinning of electron and another is the septal quantization of the orbits in the space. First, we will discuss what is the spinning of electron. Sommerfeld assumed that the electrons are moving in an elliptical path and the nucleus is situated at one of the focus, and let us consider this is our major axis, this is our minor axis, and this is the focus where the nucleus is represented and the electron is moving in this orbital path. This motion is discussed by Sommerfeld model that the motion of the electron in its orbit is known as orbital motion. And due to this orbital motion, there is a mechanical angular mechanical momentum And let us consider this momentum is known as orbital momentum due to the orbital motion of the electron. And let in this case the orbital momentum is represented with the help of PL. This PL is representing the orbital motion of this electron. Added to this motion, here electron is also assumed to have a spin motion about its own axis. It means the electron is spinning as well as moving around the nucleus, and now the electron have another motion, that is spin motion. And due to this spin motion there is a mechanical momentum, and now we are mentioning it is at spin mechanical momentum. And this spin mechanical momentum is explaining the spin motion of the electron. Only these momentums would be possible if the electron is a neutral particle. But as the electron is not a neutral particle, it is a charged particle, and in both the motion, the electron is covering the whole loop. In orbital motion, it is completing this loop, and in spin motion, it is completing this loop. And due to the completion of loop, with these two momentas, there are two corresponding momentas due to the charged loop motion of the electron. As we know that if a charge or a charged particle is moving in a closed loop, let us consider there is a charged particle Q having mass m and velocity v and moving in a circular path with a radius of r. We know that this charged particle is not giving a mechanical momentum, is behaves like a magnet, and its magnetic momentum is given as the product of current into the area of the loop in which the current is moving. In our case, the charge is the charge of an electron, and we know that current is nothing else than charge flowing per unit time at a particular point. And now we will put Q is equal to E. And what is T? T is the time or time period of one revolution of the charge in this loop, and we will give this time period in the terms of the circumference, that is 2 pi r with divided by velocity. If we put this value, we will have 2 pi r into v. This is the current flowing in this loop if a electron is moving have in a loop of radius r. If the area of this loop is pi r square, then we will have the magnetic momentum of the loop in which the charge is moving, and mu. Now here this magnetic momenta, we are representing it as mu. It will become the orbital magnetic momentum. This is our magnetic momentum, and we will call it orbital magnetic momentum if we are considering the orbital motion of the electron. Hence, corresponding to this motion, there are two momentas. One is our orbital mechanical momentum, which is indicated with the help of PL, and another is our orbital magnetic momentum, because this orbital motion is producing a small magnet and given with the help of orbital magnetic momentum. And With the help of the above formula, that is current into area, we will have the value of orbital magnetic momentum mu L is equal to EVR divided by 2. If we put these two values, that is current into area, in our above relation, that is current into area, with the help of these formula we will have this. It means we get our magnetic momentum, orbital magnetic momentum, as well as our mechanical momentum for orbital motion. Similarly, we are doing that the electron is also giving us spin motion, and due to the spin motion, we can explain the spin mechanical momentum as well as our spin magnetic momentum. And the spin is twice as compared to the orbital motion. If we double this, we will have EVR. And now we know very well know that the orbital momentum can be converted into angular momentum, or we can easily find out the VR relation with orbital momentum. Our linear momentum is given by the rest mass of the electron, velocity of the electron, and into r. This is our angular momentum as the body is moving in angle or in rotational motion or in curve. From here we will have m naught, that is PL divided by m naught is equal to VR, and if we put these relation in the above, we will get PL divided by, that is mechanical momentum, magnetic mechanical momentum divided by our orbital momentum, comes out to be having relation E upon 2 times of m naught in case of our orbital motion, and it will be the ratio of magnetic spin magnetic momentum and spin mechanical momentum comes out to be E divided by m naught, and hence due to the motion of the electron we will have two magnetic momentums, that one is our orbital magnetic momentum and another is our spin magnetic momentum, and we have two mechanical momentums. Again, one is regarding to our orbital motion and another is regarding to our spin motion. And due to the interaction of all these four momentas, we are able to find the or explain the fine structure, or we can say the multiplet structure of the spectra very easily. Second feature, that is septal quantization of the orbit, explain that if we are considering the motion of the electron in according to the Sommerfeld atomic model, there are only two variables. One is our radial velocity vector and another is our angle. And hence, according to the Sommerfeld atomic model, the motion of the electron is a planar motion having two variables r and theta. According to vector atomic model, the motion of the electron is not planar, it is a three-dimensional motion. It means the electron can move in any plane. Maybe it is xy plane, yz plane. It means it is moving in three space or three coordinates will change in this case. It means if we have given this, or we have to represent this orbit, we are not specific that this orbit will be in x y plane, or it is in yz plane, or it is in xy plane. It means it has a large number. It may be considered, the electron may be moving in any three-dimensional plane, but according to vector atomic model, the orbit is fixed in three-dimensional plane. It is quantized, or it is fixed in magnitude as well as in direction. Even though the orbit is three-dimensional, we can predict the magnitude of the elliptical path and the direction of the elliptical path. Let us consider the motion of the top. When the top moves along its axis, it can move in this path, it can move in this path, it can move in this path. Similarly, our electron can move in this orbit, or in this orbit, or in this orbit, or in this orbit. We can easily, with the help of an experiment, find out these orbits are quantized. It means not every elliptical orbit is there in which electron can move. From all these infinite number of orbits, only some specific orbits, that is quantized orbits, are there in which the electron is moving. Let us consider the electron is moving in one of these orbits, and we apply the magnetic field perpendicular to the given atom, or to the given motion of the electron. We know that if electron is moving in, let us consider this is our applied magnetic field along z-axis, and the electron is moving in one of the elliptical paths in three-dimensional, and this is the direction of our angular velocity, making an angle of theta, and we don't know whether this omega is for this path, for this path. We are only finding out that the electron is moving in one of all these many infinite choices. We know that now on the application of magnetic field, the electron will start to move about this magnetic field, and this path depends upon the projection of our angular velocity on the applied magnetic field, that is our omega cos theta. Here theta comes out to be very specific every time when we applied magnetic field. This is the indirect method. For one orbit we are getting one projection. If we make h smaller and smaller and make it tends to 0, we can give the accurate magnitude as well as the direction of our elliptical orbit. This is the indirect method. It is showing that one path is corresponding to one projection of angular velocity on our magnetic field. Hence, this is our vector atomic model, and it gives us two new characteristics or features about the atomic model, which is not previously explained by the Summerfield atomic model, we in vector atomic model we introduce two new things. One is spin motion of the electron, due to which there are four momentas. Two are mechanical momentas, that is orbital mechanical momentum and spin mechanical momentum, and two momentas are magnetic momentas, which are named as orbital magnetic momenta and spin magnetic momenta. Second feature which is introduced by the vector atomic model is that the elliptical paths are three-dimensional paths, and these three-dimensional paths are not of infinite number. They are fixed in space, they are quantized in space, they have fixed magnitude as well as direction, and with the help of indirect method, by the application of magnetic field, we can find out the projection of our circular path on the magnetic field, due to which it start to precess around the magnetic field. For one orbit we have single precession. For two orbits we will get two different type of precessions, and by making applied magnetic field zero, we can easily find out the quantized septal orbit.